Okay, so let's continue on with arithmetic operators, and this time we will migrate to float numbers. We're going to do an addition, subtraction, multiplication, and division, okay? And then, as promised before, we're going to mix floats and integers and see what the issues are and why it's important to stay consistent and assign the appropriate data type for the appropriate scenario, okay? All right, so we're doing example 9.cpp. Okay, so let me save that. And again, let me just go to example 8. Example 8, this is what we did in the previous video. Okay, we added two numbers at runtime. Actually, we asked for the user to enter values at runtime, which are the assignments. And we did the actual operation within this cout statement or within the stream when we printed it out. And also we managed to actually print the values for num1 and num2 within the same stream. We could do something similar. We could have an intermediate variable like result to hold our actual result. We didn't do that in example 8. We may do it in example 9. So let's go ahead and at this stage have a float type, okay, variables. So in C++, you would see three types of floats like we've seen before: float itself, double, or long double. And that depends on the size of the numbers you're handling, okay? If they're very big, then you probably or we'll choose long double. Most of the time in C++, you're going to see actually double. Rarely you would see float. We would use float, and that's for backward compatibility with C, which used float and didn't use the keyword double. So in our case, we're in C++, we're not in C, so we might as well declare something of type double. Let's call it num1, num2, and result. All right, so similar to what we've done with integer. So I have three variables, okay? Num1, num2, and result of type double. I have not initialized these values. So that means now we can go ahead and ask the user to enter a value for num1 and num2. Notice it's not any different than what we've done with integers in terms of how we interact with the user. So cout, enter a float value. Now, technically, double is a float, okay? So nothing wrong with that. And then from a user point of view, that's totally transparent. They're not going to know the difference between a double and a float. For them, it's a real number, which means it has a decimal value, a decimal point, right? Or it could be entered as an integer, but it's converted automatically into a float. So if you entered 7, it will automatically be changed for you as a 7.0. And it will occupy that many bits, depending on the size, if it's double, float, or long double, right? It will be padded if the number doesn't reach all of the bits required to hold that number. Okay, so right here, we're going to do num1. And then we're going to do the same thing for the second number. Same thing. And we're going to do cin num2. Now we could say result equals num1 plus num2. Okay? And now we could print the result. So cout. And then you could do something like this, num1. If you just simply want to print what they are to remind the user what they entered, num2 and then result. And end the line here. And let's see how this behaves, okay? All right, so let's compile and run. And you can see my console is a little small, so I'm going to change its properties. Pick a different font family, change it to 36, and we got something a little bigger. So we're at num1, so it's blinking right here on the same line. So let's say we enter 2.3, okay? And then the second value will be a 1.1, right? So in the end, we should end up with 3.4. So let's see if we do. And sure enough, we end up with 3.4, okay? Now let me run this program again and enter the values as if they're integers, 3 and 2, okay? And you get a value that looks almost like an integer, but we know internally that 5 there is an actual float value. Now, later on in another lesson, we'll learn how to modify the output to actually set the precision to how many digits you want after the decimal point, all right? So that might be important in some applications where you have to set the precision. Here, it's automatically adjusting itself to what you're playing with. So let's do a mix of, let's run it again, something that has a decimal point, 1.1 for example, and let's enter 4.9, okay? And let's see what the result looks like, right? I did this on purpose, and as you can see, this should have been a 6.0, but in its raw form, the display will show as if it's an integer, but we know this is not an integer. So keep that into account, because later on, we're going to have to be a little more precise in our cout statement, which means result, okay, has to be shown with some precision set to either at 1 decimal point, 2 decimal points, etc., etc. Again, it all depends on the requirements in which your application lives in, okay? All right, so if this was a physics measurement and you are supposed to round up to 1 decimal point, then your final result should be about 1 decimal point as well, okay? So that should have been a 6.0, right, to be precise. Otherwise, you know, if you were taking an exam and this is an actual physics measurements, you probably will have points taken out. So be careful with that sort of thing in school, okay? All right, so as you can see, all right, the environment in which cout prints things around, it could round it up without the decimal point. So we need to set the precision to be clear that that's what we're looking at, okay? So in our next video, we will do some set precision functions that will allow us to do things a little more correct. All right, so let's continue and do a subtraction now. What if I did result equals num1 minus num2? Notice I'm reusing the variable result. You could redeclare a new variable. You cannot redeclare result, by the way. If you do this, double result, that would be illegal. So notice if I try to compile this, it will say that that has already been declared right here. So don't do that. If you want to reuse it, that's fine. Go ahead and reuse it, as long as you don't care what's stored in it after you were done with it. Okay, when were we done with it? Right here, right? So if we don't need that result of the addition, and we need to now store the result of a subtraction, we can go for it, right? And we could go ahead and now display num1 minus, and notice this is a string literal, okay? So the operation has been done already. It's the line above it. Right now, we're just showing what we just did right prior to printing to the screen. And that would be a result. And now let's see how this looks. Don't forget to do that, okay? All right, so let's compile and run. All right, so let's say we enter 2.3 again, and let's say we enter 7.1, All right, so as you can see, the result of that addition is 9.4. The result of the subtraction is minus 4.8. Okay, so now let's look at a couple more operators, which is the multiply and the divide. So what I'm going to do is copy this part, just for the sake of time, and repeat it twice, and repeat it one more time. And this time, this would be a multiplication. And you could show that you are doing a multiplication. And this here will be a division. And you could show that's what you're doing. It's a division, right? So we've entered two numbers. We're going to do all of these operations on it, just so we can see that you can actually use these operators, plus, minus, asterisk, which is for multiply, and / for division. Now we have to be careful. I haven't introduced you to conditional programming, in which you have to verify that num2 is not 0, okay? If num2 is 0, we're going to get an error. So I'm going to do that on purpose in a minute, and when we replay this program. So let's go ahead and compile it first, since I made some changes. So I'm compiling it. So let's say I have a value of 1.1 for the first number and 0.9 for the second number, right? So here are the results. So 1.1 plus 0.9 is 2. 1.1 minus 0.9 is 0.2. 1.1 multiplied by 0.9 is 0.99. And 1.1 divided by 0.9 is 1.2222. Now let's suppose my second value was a 0. And that would be a big no-no typically. So let me run it again, right? Because we will be dividing by 0. So let's say we have an 8.7 for the first number, and then I enter a 0, right? So let's see what happens. And you get this INF, or like infinity kind of result. This shows you there is an error. You can't really divide by 0. All other operations are permissible to add either a 0, subtract 0 from it, or multiply by 0. That's not a problem, right? So 8.7 times 0 is 0. But 8.7 divided by 0, that gives you an error. And this is where we will have to use what we call if statements, or conditional programming, to evaluate, okay, the second component in this operation to make sure that it's not 0 before you do the division. That's another lesson. Okay, so I hope you had a good introduction to the arithmetic operators. I am going to go ahead for the next video, do an example, a practical example, right? And what we'll do is like the area of a circle, for example. But we're going to set the precision to, let's say you measure the radius at 1 decimal point. Then we would like to set the precision accordingly. Okay? All right, fantastic. So I will see you then for the next video, and I hope it will be very informative.